Now we're going to talk about the vertex of a parabola, which is one of the most important characteristics of a quadratic graph. Let's start by defining the term. Remember that there are two possible shapes that a parabola can have, either an upward-facing shape or a downward-facing shape. In either case, there is a point where the graph changes direction. In the upward-facing graph here, we are going down, and then we're going up. Right, there is a point here where we change direction. And same thing with the other graph. Here we're going up, and then we're going down, and there's this point in the middle where the graph changes direction. That point is called the vertex of the parabola. In many ways, the vertex is the central point on the parabola. It is, in fact, in the middle of the graph. And even more than that, if we were to draw the vertical line directly through the vertex, the graph would actually be a mirror image of itself on each side. That vertical line that cuts the graph in half is called the axis of symmetry, and it always runs through the vertex. Another important fact about the vertex is that it is also the highest or the lowest point on any parabola. In this case, the vertex is the lowest point on the parabola. In this case, the vertex is the highest point on the parabola. This is really important in applications. For instance, suppose you are a business owner, and this lower graph here represents a graph of your profit. Well, as a business owner, you would want to be up here at the maximum possible profit, and so finding the vertex is often an important thing to do. Well, if the vertex is such an important point, it begs the question of how do you find it? It turns out that there's a pretty easy way to find the vertex of a parabola from its formula. The vertex is a point, and so it has two coordinates, an x-coordinate and a y-coordinate, and it turns out that there is a nice easy formula that will tell you what the x-coordinate is. Here is the formula, negative b over 2a. For any quadratic function, if you want to know the vertex, you can take the values of b and a and plug them into the formula here, and that will tell you the x-coordinate. So then, what about the y-coordinate? Well, the vertex is just like any other point. If you know what the x value is and you want to know the y value, you take that number and you plug it in to the function itself. In other words, the y-coordinate of the vertex is f of the x-coordinate, or if you want to be a little more specific, f of negative b over 2a. Let's do an example of finding the vertex and sketching the graph. So we're given this function, f of x equals negative x squared plus 4x minus 3, and we need to find the vertex and also sketch the graph. As always with a quadratic function, it's a good idea to write down the values of a, b, and c because we're going to be using them. In this case, we have a is negative 1, we have b as 4, and c is negative 3. So to find the vertex, we can first apply the formula for the x-coordinate. xv is equal to negative b over 2a. Now in this case, negative b is negative 4, and 2 times negative 1 on the bottom. That's negative 4 divided by negative 2, which is positive 2. So we know that the coordinates of our vertex are going to be 2 comma something, and we need to figure out that y-coordinate. Well, since we know the x-coordinate, it's a matter of simply plugging in that value for x to the function and see what we get. So the y-coordinate is going to be f of 2, which in this case is negative 2 squared plus 4 times 2 minus 3. That's negative 4 plus 8 is positive 4, minus 3 is 1. So now we know that our vertex lies on the point 2, 1, and let's go ahead and plot it up here in the graph. Now we are also asked to draw a sketch of the parabola, and for that we're going to have to bring in a little bit more information. For one thing, if we look up here, we see that the value of a is -1. Since it's less than 0, that means that our parabola will have to be a downward-facing parabola. In addition, we can look at the value of c here, -3, and that tells us what the y-intercept is. It's going to have to be at -3. So we can go ahead and plot that point as well. And so what we want to sketch is a downward-facing parabola that has its vertex at 2, 1 and also passes through the point 0, -3. So the graph is going to look something like that. And from our picture, we can tell now that the maximum value that our function will ever achieve is 1. That's as high as the graph ever goes. And it achieves that value when x equals 2.